All right, so let's look at this homework packet that is a review of things that we've been learning in Module 1 about proportionality to help us get ready for this test coming up. So here on the front it says, when a book is sold on Amazon.com, Amazon gets the money from the sale, but they pay some of it to the author. It doesn't really work like that in real life, but kind of, sort of. The table below shows how much money is paid to the author in relation to the total amount of money brought in by selling the book on Amazon. So we've got some X values here, which is going to represent the revenue. That's the money brought in, made from Amazon.com sales. And then we have some Y values here that will represent the amount of money paid to the author based on the sales of the book. And so part 1 here, they want us to make a graph. And before we start any graph, we're always thoughtful about how we're going to scale the graph, how we're going to put the numbers on the y-axis and on the x-axis based on what values we're going to wind up graphing here. So I see on the x-axis I need to do 300, 400, and all the way up to 900. And I already counted earlier. I know that this is 20 boxes wide and 20 boxes tall. And so if I were to do 100 for every other box, that would get me to 1,000, and that would work pretty well for needing to get to 100. And then here, I see that I need to get to 225, and all these numbers here, 75, 100, and 225, I know that they're all multiples of 25. And so if I were to do 25 on every other box here, that would give me 10 increments of 25, which would get me to 250. So yeah, I think that's how I'm going to do it, is by 25s on every other box here and by 100s every other box on the x-axis. So let me draw the axes out first. So I'll put in my y-axis, and I'll put in my x-axis. I got to turn the paper to do that. Then I'll start my scaling. Try to do this really neat. So when you go to do this on the test, your neatness and how thorough you are on your graph is going to be a big deal, whether you've scaled it nicely in a way that makes sense, whether you plot the points accurately, whether you make sure to label the quantities on both sides here, on both axes. One of the biggest things that we see students lose points on this test all the time is the scaling. So I decided that I'm going to go 100 every other box down here on the x-axis. And for some reason, students do this all the time. They might put 100 as the first box and then start skipping and go 2 boxes 200, 2 more boxes 300. But you can't do that. If you can't just use 1 box for 100 and then 2 boxes for every 100 after that. That's called uneven scaling. Also, students lose points because they'll use the very first line here to mean 100 or 50 or 10, whatever they're doing. But you can't use the first line. That's the y-axis, and that's where the origin is. That's 0. You can't start there. So make sure that whatever spacing you choose, it's the same the whole way through. So I'm going to do 100, 200, 300, 400, 500, 600, 700, 800, 900, and I could stop there, but I guess, no, I am going to stop there because I'm going to save this little space down here to be able to label the axis, because there's not really any good space for me to do it under the numbers where I would normally do it. So I'm going to write over here, dollars paid to author. No, I'm not. Oh, I totally just messed that up. I accidentally just put my Y quantity down here on my x-axis. Oh, so this is going to be messy now. Oh well, things happen. That's okay. So I really meant to put money made by Amazon down here. And I'm just going to draw an arrow to here to mean that that's the x-axis. And then, all right, before I even get started over here, I'm going to write dollars paid to the author up here, so I don't forget that and I don't mess it up. And then I'm going to go 25 every other box. So this will be 25, 50, 75, 100, 125, 150, 175, 200, 225, and I guess we probably won't really need it, but I'll mark 250. And now I'm going to graph these points. So I have the point 300, comma 75. So I go to 300 on the x-axis and 75 on the y, and then 400, comma 100, and 900, comma 225. That'll be right here. All right, so this particular relationship does turn out to be proportional, so hopefully your points make a nice straight line that goes through the origin. So I'm going to connect the whole thing. I missed my dots by a little bit, but it doesn't have to be that perfect. It needs to be really nice, neat, clean. It needs to have all the labeling done, the scaling done well, the plots pointed. That's what matters. If you want to be extra thorough, I suppose you could label some of the points, like this is the point 400, comma 100. But that's not super necessary. All right, let's go on to the next page. So it says, identify the constant of proportionality between dollars paid to the author and dollars brought in from sales on Amazon. Well, constants of proportionality, or K, are always found by doing a y value divided by an x value. So all we have to do is pick a y value from the relationship and divide it by its associated x value. And we could pull those values from the graph by looking at points, right? This is a y value and this is an x value. Or we could go up to the table. Here's a y value and here's an x value. You could use any of these pairs of values. I'm going to use 100 and 400 just because I feel like those are the easiest ones in order to like divide or simplify a fraction with. So let's be super sure so I don't mess this up. The 100 is the y value, so it's going to go on top. The 400 is the x value, so it goes on bottom. So 100 divided by 400. And I know that 100 goes into 100 and it goes into 400. So I can divide the top and bottom of this by 100 and I get 1/4. So just to be super clear, I'm going to write that K equals 1/4. So what that means is it looks like the author is getting 1/4 of the money that Amazon's getting. All right, write an equation relating the dollars earned by the author to the dollars brought in by Amazon, and the author is Y and Amazon is X. Well, this is pretty simple. We have this equation that we call the general form of a proportional relationship equation, and it's just Y equals KX. And all you have to do to write the equation of a specific relationship is take the K that you found for that relationship, which in this case was 1/4, and just put it right where the K goes in the general form. So our equation is Y equals 1/4 X. That's all we need. All right, the next one says, according to this proportional relationship, how much money must the book have brought in from sales on Amazon if the author was paid $600? So the author made $600, and let me just triple check. The money that the author makes is always a Y value. So if we have this equation right here, Y equals 1/4 X, but this is like now a Y value, this 600 here. So I could write the equation 600 equals 1/4 X. And my job is to figure out what X equals. In other words, how much money did Amazon make? There's a lot of different ways you could think of this. You could think, okay, well, if X times 1/4 equals 600, I could go backwards and say, well, 600 divided by 1/4 must equal X. Another way you could think about it is, oh, well, if the author always gets 1/4 of the money that Amazon gets, then let me just take this 600 and times it by 4, because that'll get me 4 times as much, and that's how much Amazon should get. Either way you want to think of it, both of those will work. What's good here is that either way we're going to wind up multiplying by 4, because this 600 divided by 1/4 here, well, if I turn 600 into a fraction, 600 over 1, and I want to do this 600 divided by 1/4, I'm just going to do it as a keep, change, flip. I'll keep 600 over 1. I'll change the multiplication. I flip to 4 over 1. And 600 times 4 is 2,400. So let's write a little conclusion. Amazon made 2,400 or 2,400, depending on how you like to say it, dollars in sales. Sales revenue, if you wanted to be even more thorough. All right, and then the last one for, I think just for this section, says write an ordered pair. Remember, that's two numbers separated by a comma in parentheses that represents a point on a graph. They're used for other things too, but usually representing a point in a graph on what we do. The ordered pair is supposed to represent the amount of money that the author gets if Amazon gets $500 in sales revenue. So Amazon, those are our x values. So this is like having x in this equation, y equals 1/4 x. So y equals 1/4, not times x, but times 500. So in other words, we're trying to find 1/4 of 500. And you could do this as fraction multiplication. You could think of it as 1/4 times 500 over 1, and you get 500 over 4. But that just means 500 divided by 4. So if you were already thinking, oh, all I got to do is divide by 4, then you were right. That's another way you could just answer this question. And 500 divided by 4 is $125. So we're not done yet, though. So this is like our y value here, right? It's because we started with y equals some stuff, and we did all that stuff, and we got 125. So that's y. And so we need to write an ordered pair. Well, the x value is 500, and the y value is 125. So the point on the graph for the ordered pair that represents this would be 500, 125. All right, let's move on to the other part about Lily and her rainfall gauge. It says, am I on the screen here? Kind of. Lily decided to measure the rainfall outside of her house, so she set up a rain gauge. After half an hour, the rain gauge showed that 1/8 of an inch of rain had fallen. So let me just write this here so I can keep track of it. It's 1/2 of an hour to 1/8 of an inch. That's sort of like the ratio that we were given to start this problem with, right? 1/2 of an hour, 1/8 of an inch. So what is the unit rate at which the water is falling in inches per hour? That means to do inches divided by hours. And so there's a couple different ways you could approach this problem. You could think, okay, well, let me just do the inches divided by the hours. Or you could also just think, well, wait, I just need an equivalent ratio here. I want to know how many inches fall every 1 hour, and I already know how much rainfall falls every half hour. So if you just double this, right, if you just multiply this by 2, then you would multiply this by 2, right? So if we have the ratio 1/2 hour to 1/8 of an inch, and then we just multiply both sides of the ratio by 2, then over here you would get 1 full hour, and over here you would get 2/8, which is the same as 1/4. And so that's going to be your unit rate right there, 1/4 of an inch per 1 hour. Another way you could have done it is inches divided by hours. So you could have done 1/8 of an inch divided by 1/2 of an hour. But when you keep change flip that, you wind up doing 1/8 times 2 over 1, which again is 2/8, which also equals 1/4. So whichever way you're thinking about doing this problem is fine. Either way, you should have got 1/4 of an inch per hour of rainfall. Write an equation that represents the relationship between the number of inches of rain, y, and the hours, x. Well, since we have our k, right, this is a unit rate, but it's also k, we just use our general form, y equals kx, and we just take this from the previous one. You know what, I didn't realize when I made this, both equations turn out to be y equals 1/4 x. Maybe I should change that to a little more variety in the future. All right, so the amount of rain equals 1/4 times the hours. You get 1/4 of an inch every hour, so y equals 1/4 x. All right, and then the last question. Assuming the rain continues to fall at the same rate, how long will it take for 1.25 inches of rain to fall? Please provide two answers, one in hours and one in minutes. All right, so we have 1.25 inches, and that's the y value in our equation here, right? So essentially what we want to know is you know what, I like fractions so much better. Hold on. I'm not going to use 1.25. 1.25, that's the same as 1 1/4, and that's the same as 5/4. I prefer fractions all the time. So this is our y value, right? This is an amount of rain, 1.25 or 5/4 inches of rain, and that's y. So I can just rewrite this equation up here, but with this 5/4 for the y. So 5/4 equals 1/4 times however many hours it takes. Well, you could think, oh, I need to do 5/4 divided by 1/4, but you could also just think, wait, what does this x have to be so that when I multiply it by 1/4, I get 5/4? Hopefully that seems kind of self-explanatory, that means that x must equal 5, right? If you need some number times 1/4 has to equal 5/4, well, that number has to be 5/1, or just 5. So it sounds to me like you need 5 hours for 1.25 or 1 1/4 inches of rain. The problem said to give 2 answers, one in hours and one in minutes. Please remember that there's 60 minutes in an hour. I'm going to leave that one last little part for you to do because I did the rest of this with you. All right, write another answer, same thing, but just in minutes instead of hours. All right.